Hey everyone, my name is Ayush Gupta and I am a pre-final year student currently pursuing Electronics and Communication Engineering from SRM Institute of Science and Technology, Kalathur. Today I'll be giving a presentation on a recent Embedded Systems online internship that I did in Emertxe Information Technologies, and the title of my project that I did in the internship was a car black box. So before actually moving on to the project and explaining a little about it, I'd just like to explain some things that were covered in the internship and what all did I get from doing the internship. So yeah, these were some of the questions that were discussed before the actual internship began, and these were really interesting questions because they capture the interest of every person who is undergoing the internship program. Like, we need to know why are embedded systems so important, and what kind of role do these embedded systems play in my life, how do they affect me, what kind of devices that I use are have embedded systems inside of them, and like what is an MCU inside an embedded system, a microcontroller unit, what is it, how does it help the embedded system do those specific tasks for which they are designed. Then what are PIC microcontrollers and how do these work, and how to control these PIC microcontrollers using programs written in C and embedded C, and how from all of this knowledge, after gaining all of this knowledge, how can we build many amazing projects such as the one we did in the internship, which is a car black box. So moving on to the next slide, these were some of the key takeaways from the internship. So beginning with a general overview or a general introduction to our the base of all languages, that is C language. What are all the keywords, operators, arrays, functions, pointers, the strings involved in C, what are the preprocessor directives. Then after covering all of these things, we learnt about embedded systems, what kind of embedded systems are there in our daily lives, what are the types of embedded systems, and then we moved on to what are microcontrollers and how do these microcontrollers differ from a term which is generally confused with, that is microprocessors. Sometimes people confuse microprocessors with microcontrollers, so these were also covered in the internship and explained in a very nice way how do these two differ. Then we have our car black box project, and what are the tools or what were the software that we use, that is MPLAB XID, X8 compiler and PiximLab, which using these only we were able to complete our project. And how how did we do that project, what was the implementation process, how we implemented the logic that we learned in the C programming into our program that we wrote for the project. So all of that using interrupts, timers, and what were the peripherals. And the most important thing, the microcontroller which we were programming was PIC 16F877A. This was the microcontroller which was focused in the internship, and this microcontroller is there in PiximLab, which I will be showing in the project demo later. And how all of these IO components such as keypad, CLCD, how all these things put together helped in the car black box project. And I'll be explaining that in the project explanation later in the video. So moving on to the next slide, what is C programming? So C is generally a simple general purpose language. It is a high level language. Yes, of course it is a high level language, which was originally developed by Dennis Emrigi to develop Unix, that is Linux based operating systems, at Bell Labs. So C was originally not meant for so many vast applications as we know. Initially, C was only designed for a DEC PDP-11 computer in 1972. Back then, they did not know that this language would be the one that now has that now is serving as the base of all the assemblers and compilers that we have. It is a very widely used and it is a very professional and flexible language for many reasons, such as it is easy to learn. It is not a very complex language. It is a structured language. Its format is very structured, the syntax that we have, and the efficiency of the programs that we have in C is very good. So yeah, now coming on to C keywords, there are many different types of reserved keywords. Like, these keywords are reserved because you cannot name a variable with the name of these keywords. It would throw a syntax error because these are reserved for special functions only. So yeah, as it is mentioned, these reserved words may not be used as constant or variables or any other identifier names, because they serve a very specific purpose in the program of C. So they cannot be used as a variable or some other identifier name. Some of them are like break, case, then we have char, we have default, int, double, size of, void, null, all of these things, all of these keywords that come under C keywords. Then we have the different types of operators. So what is basically an operator? It is a simple symbol that tells our C compiler to perform any kind of mathematical, relational, logical operation or any other operation that we want our program to perform. So C has a lot of operators. It is rich in operators, in built-in operators, and some of them are like arithmetic operators, plus, minus, divide, modulus, and relational operators, greater than, less than, logical, bitwise, so on and so forth. Then comes a very important aspect in C programming language, that is arrays. So C provides, array is what? It is a data structure. So C provides a data structure called array, which can store a fixed size sequential collection of elements of the same type. What does that mean? So array is like a storage place. It is a box where you can store some information or some data which can be of the same type. So it can store like 10 variables, which can, on all of these variables can be of integer type. That is how arrays work. And an array is used to store, like as it is said, a collection of data, but it is often more useful to think of array as a collection of variables of same type. So instead of like if I want to declare three variables, so instead of like declaring int a, int b, int c, what I can do is I can declare an array of size 3, and in that array should be of data type int, and in that array I can have all these three variables which I was earlier declaring individually. So that is how arrays can serve the function of collecting data under one single type. And so if so as it is mentioned, instead of declaring individual variables such as number 0, number 1, so on and so forth, I can just declare one array variable of size 100, and I can access those individual uh, array elements using a certain feature called index, array index. So a specific element in an array, any single element of an array can be accessed by an index, and all these array consists of contiguous memory. These elements of arrays are present in different memory locations, contiguous memory locations. So the lowest address, obviously in case of arrays, since it is a since it is collection of data, so every element has its address. So the lowest address element is the first element in the array, which starts from not 1 but a 0, and then the highest address of the highest address is the last element inside the array, which will be having an index of n minus 1, n being the size of the array. Then comes C function. So every C program has a function, as the name suggests, to perform any specific task, or it is a function is nothing but it is a group of statements. It is a statement or a group of statements written to perform a unique task, and that function, we can divide up our code into those different kinds of functions, and how we divide our code among different functions is up to us. But logically, the division of each function is done so that we can perform a specific task only. So a function declaration tells our compiler about its name, its return type, or whether it is a void type, and the function parameters. What kind of parameters are we passing? An integer variable? Are we passing a double or a float? Those are the parameters of the function. And here is the general syntax. So we have a return type, which can also be void. Then we have the function name, x, y, z, a, b, c, d, anything. Then we have the parameter list, int a, int b, so on and so forth. And then inside that body, in the body of the function, we have the statements from which we get the desired task being performed by the function. Then we have pointers in C. So pointers are very unique feature in C, and they actually, every variable that we have, So every variable is a memory location, and that particular memory location or memory address is what we need to access, and this is where pointers come in. So every pointer, as we can see in the image here, so every pointer points to the address of a variable. For example, if I have an array of size 6, and inside that array the first element is h, so if I want to access h, I can declare a pointer I can declare a pointer by ptr star ptr, and that pointer will point to the address location of h, which is always an integer. For example, if that address location is 1000, then that pointer will not directly point to h, it will point to the address location of h. So that pointer will hold the value of that address, and that is how pointers work. So yeah, so now comes strings. So string in C language, string is nothing but it is an array of characters. It is a string, unlike other high level programming languages such as Java or Python, where you can directly declare a string. In case of to declare a string, we need to declare a character array. So in C, a string is nothing but a one-dimensional array of characters, and always it is terminated by null character /0. Thus, a null terminated string contains characters that comprise the string followed by a null. The following declaration and initialization create a string consists. So here we can see that a string is being initialized, and then it has the value hello inside of it. So how it is being represented in the memory, inside the memory it is represented as a array which has 6 different characters, the last one being the null. So all the strings in C are terminated by a null. So preprocessors, so these preprocessors are now in C, these preprocessors are not actually the part of the compiler, but they work separately when the compilation process starts. So simple terms, C preprocessor is just a text substitution tool, and they tell our compiler, they guide the compiler to do required pre-processing before the compiler actually starts compiling the program. So we have many different preprocessor commands, and all these commands have one thing in common: they all start with a hash. So if I want to declare a preprocessor directive in C, it has to begin with a hash. There are many of them: hashtag define, hashtag include, hashtag typedef, hashtag if else, so on and so forth. Now comes our most discussed topic in the internship, which is embedded systems. So what are embedded systems? So embedded systems are nothing but obviously they are a computer system that are usually a part of another big electronic equipment or one of the big computing system. So they consist of a microcontroller. Inside the microcontroller is basically the heart of the embedded system. All embedded systems have a microcontroller inside of them. These microcontrollers perform that unique task or that specific task for which the embedded system was designed in a product, and they can be found in almost every modern piece of technology that we are using today. These systems are the ones where we see that computer hardware is being integrated with computer software, which is nothing but code. It can be C code, and these two, when integrated together, they perform that unique task which we users want in our daily lives. So that is how embedded systems work. Then we have a block diagram of any typical embedded system. It will have a processor, and with that processor, it will try to communicate with the sensors, with the actuators, and communication interfaces will be there. All these things communicate with each other. We have the RAM, we have the flash storage, clock is there. So all of this is inside the microcontroller. The RAM, flash, clock source, processor, all of this is inside the microcontroller, inside the MCU. That is what we program so that it can interact with the outside world's sensors it can interact with the communication interfaces to perform those tasks that it was designed for. So and also it can have several AD or digital to analog conversions. It can have timers inside of it, counters, so on and so forth. So what are the types of, there are four basic types of embedded systems. The first one being standalone, and as the name suggests, they don't work under any host, or they don't work under any particular big computing system. They are independent, they work by themselves, they do not require any host system as such. So for example, we can have a temperature measurement device which works on itself only. So then we have real time embedded systems. So majority of embedded systems that we have operate with real time software. What does that mean? It means that they give their required output function within a specified time interval. That is why the term real time embedded systems. Then we have network embedded systems, which work in a device or machine that is connected to a bigger network that provides output to other systems. So they can we can find these network embedded systems quite frequently in our home security systems, office security systems, and because these places have a much more complex network connected. So then we have mobile embedded systems, which obviously, as the name suggests, they can be in our smartwatches, and they can be, these basically are portable. They we can take these kind of embedded systems, the products that are designed with mobile embedded systems, we can take them anywhere. Our smartwatches, then we have smart bands and mobile and small devices that we use in our daily lives. Now comes a very basic difference, that is microcontrollers and microprocessors. How do they differ? So microcontroller is an entire computer in its own definition. It is a single IC, it is a single integrated chip that consists of relatively simpler CPU, that is a central processing unit. Every MCU has its own processor inside of it, as it was shown in the block diagram earlier. And this CPU is combined with the peripheral devices such as memories, input outputs, timers, and so on and so forth. So this MCU, everything that the MCU has, it is inside of it already. So this is how the IC of an MCU is designed. Everything is inside of it: the RAM, the flash memory, input output peripherals, everything. It acts as the heart of the embedded system. And since on-chip memory and IO component is available, therefore the integrated circuit of a microcontroller is less complex in nature. Now comes the microprocessor. Microprocessor is it is also a circuit only, but a microprocessor is generally a central processing unit on a computing system, which is generally designed on a single IC consisting of many and many millions and millions of transistors which work together, and these transistors act as the heart of any computing system. And all the other memory units, RAM, flash memory, input output peripherals, all these things in a microprocessor are connected externally. In case of a microcontroller, it has everything inside of it, so it is an entire computer in itself, a microcontroller. But a microprocessor, everything is connected to it externally apart from an ALU. And therefore, because of this reason only, the circuit of a microprocessor becomes much more complex. Now comes the project. So what is a car black box, and how is it so important in the applications, in the application in the real world? So a car black box is a device which is generally installed in an automobile, such as in an automobile. And this device is installed so that we can monitor certain different events, such as the speed of the car, the gear change of the car, location, GPS, acceleration. But most importantly, it is used so that we can track and record events like accidents that happen. And this device, this car black box, the most important purpose that it has is that it can record these events, these things that happen before the accident of the car, so that when the time comes, the accident can be investigated to find what caused the accident in the first place. So these black box devices, these car black box devices, they record these accident events and what things that happened before the event as well, so that one can investigate or know what actually was the cause behind that. So it is also sometimes referred as event data recorder because it records events. Now the block diagram of the car black box is such that the PIC 16F877A MCU is communicating with the real-time clock and internal EEPROM using I2C protocol, and it is also communicating with the 16 cross 2 CLCD display, the matrix keypad, and the pot, which is the variable resistor. So these are some of the project requisites. So before moving on to implementing the project, one must have some basic knowledge or some good knowledge of embedded C coding, and then it's important to install MPLAB XID and the XC8 compiler on which the embedded C code was compiled. And then the hardware side of things, in order to simulate what kind of circuit would what kind of how that code would function if it were dumped on a real microcontroller. So for that we have the PICSIM lab. It has the PIC 16F877A MCU as discussed earlier. Then as discussed earlier, all those matrix keypad, CLCD, all those IO devices which will be used in designing the car black box. This is the PICSIM lab architecture where PIC 16F877A is the MCU, and all other IO devices, how the COM protocol, how the COM protocols, and all these things, how do they communicate with it? That is how the architecture of PICSIM lab is. This is the pin diagram which was taken for reference while writing the code in embedded C for the car black box. Using this pin diagram only, we get to know that which port we have to interface, which port we have to make high or low, so that we can get the desired functionality while implementing the code, or while we are seeing the code work on the emulator or on the PICSIM lab. So what are interrupts and what are ISRs? So as the name suggests, interrupts, so they interrupt, they stop something, they stop. What do they stop? So these are very special events that require very immediate or instant attention, and they stop the microprocessor from doing the current task, so that they can let the microcontroller know that something has happened, please stop the current task and we need immediate attention. So they do that by signaling to the processor, and this signal is emitted by hardware or software, and which basically indicates that some immediate attention is needed. So whenever an interrupt occurs, the controller completes it first completes the execution of current instruction and starts the execution of a interrupt service routine, or the ISR in short form, or it is also called as interrupt handler because it handles these interrupt requests. ISR tells the processor or controller what to do when this interrupt has occurred. The interrupts can be either hardware interrupts, or they are of two types. They can be either hardware or software interrupts. So hardware interrupts are like when some change has occurred in the circuit, or the circuit is not functioning as expected, or some undesirable changes have occurred. Software interrupts are the problems that are there in the code that are generated in the software, and ISR attends to the request of an interrupting source by clearing the interrupt flag first. Then it should save register contents that may be affected by the code in the ISR. When an interrupt occurs, the MPU completes the instruction that is currently being executed. Then it disables the global interrupt enable and places the address from the program counter onto the slack. What are timers? These, as the name suggests, they are used to measure the time or generate accurate time delay. The microcontroller can also measure the required time delays by running loops, but the timer relieves the CPU from that redundant and repetitive task, allowing it to maximize the processing time for other tasks. So the timer, obviously, since it is a timer, So we can reconfigure it, or we can simply take it for as a binary counter, and we can configure it to count clock pulses, which can be internal, external, both ways. And once it reaches its maximum value, it will roll back to 0, setting up an overflow flag, OF flag, and generate the interrupt if enabled. And our MCU that we have used in this project, PIC16F877A, it has 3 timers inside of it. 2 of them are 8 bits, which are timer 0 and timer 2, and one is 16 bit, which is timer 1. Now comes the 16 cross 2 character liquid crystal display. CLCD stands for character liquid crystal display, and it is specifically used for displaying certain ASCII characters and some special symbols as well. It is most commonly used display in case of embedded systems. If we have a product that has an embedded system inside of it, then most of these products have this LCD display installed inside of them. This LCD display has two communication modes. The first one is 4-bit, the second one is 8-bit mode, and in our PICSIM lab we have two major types of display, which is 16 cross 2 and 16 cross 4. Now comes tactile switches, which are nothing but an electromechanical device. Since the term is switch is there, so they basically, when this switch is on, then they stop the flow of current in the circuit, and when they stop and when they are off, they basically turn on the flow of current. They allow current to pass through them, to pass through the circuit, and when they are on, the current cannot pass through the circuit. When the switch is connected, it stops the flow of current. So they are very simple, they are very cheap to interface with. And also, if the number of user inputs that we are using in our circuit, if these user IOs are very less, then these tactile switches are very preferable in those designs. Now comes matrix keypad, or in short MKP. Since it is a keypad, so it has a number of tactile switches, the push button kind of things, as you can see in the image, and these are connected in a format of rows and columns. And this is used when matrix keypad is used when more number of user inputs are required, and we still want to save some controller, the MCU. If we want to save some MCU input output lines, then we use this MKPs. And they most commonly, we can see them in telephones, we can see them in calculators, in digital lockers, in biometric lockers. All these things we can see these keypads. And now comes the RTC, which is the real-time clock, EEPROM, and potentiometer. So RTC stands for real-time clock, and as the name suggests, it is installed inside this inside a development board, so that we can keep track of the real world date and time. It measures that real world date, and time, keeps a check on it. And this RTC is itself an electronic device inside a development board. So in this project we have used DS1307 real time clock. Next comes the electrically erasable programmable read only memory, and since it is a ROM, so this type of memory allows users to erase, as the name suggests, and reprogram the stored data repeatedly in an application. In this project we have used the EEPROM, so that we can store events that are happening and the data of those events. Then potentiometer, as the name as we know that potentiometer is simply a variable resistor, and it is used in this project so that we can increase or decrease the speed depending upon the resistance in the pot. We can increase or decrease the speed, and this speed can be seen on the 16x2 CLCD display. So thank you. Yeah, so now we'd like to see the project demo and presentation. So this is the main PICSIM lab on which the entire car black box project was deployed. It has the PIC16F877A microcontroller unit integrated in the simulator, and the first screen that we see in the car black box is the dashboard screen, which shows the time synchronized with the real time clock. This is the real world date and time. And then we have the events, which shows that if collision event is happening, or if it is the on event, or if gear changes are happening, if gears are shifted up or down. Then we have speed, speed can be varied depending upon the potentiometer. So here is the potentiometer or the variable resistor, and if I change it to anti-clockwise, to clockwise or anti-clockwise, we can see how the speed is increasing or decreasing. So if I go clockwise, so you can see the speed is increasing, and if I go anti-clockwise, you can see the speed is decreasing. So this is like analog input is being taken, and depending upon that, we have the changes that are being seen in the speed. After that, we have certain events that are happening. So if I want to show the collision event, then I'll have to interface the RB0 switch. So if I press it, you can see the collision event, that is C. And if I want to show some gear changes, then for that I have RB1. So if I press RB1, you can see the gear neutral is there, neutral gear. Then we have reverse gear, so GR. Then we will have gear 1, gear 2, so on and so forth. We will have up till gear 4, and if I want to shift the gears down, for that I have RB2 switch. So if I press RB2 switch, you can see gear 3 has come, then gear 2, gear 1, so on and so forth. And all these events are being recorded in a menu, in a backend menu, which has the name of view log. So inside view log, I can see all these events, which I will just navigate to just a little bit later. Then after all these events are recorded, now if I want to see these events, so then I have to enter a password. So for that I have to, like, if I want to enter a password, for that I have to interface switch 4 or switch 5, which is RB3 or RB4, and then it will ask me to enter the password. If I enter the wrong password, so I only have 3 attempts. So after the 3 attempts, it will block me for 60 seconds if I enter the wrong password, and if I exhaust all my attempts of entering the wrong password, which is 3. After those 3 attempts of entering the wrong password, it will block me, and a 60-second timer will turn on. After that 60-second timer is over, it will again ask me to enter the password again. So I'll just present a demo of what I just explained. I'll just show it. So right now, if I press RB3 or RB4, it will ask me to enter the password, and I will intentionally enter the wrong password. So now it asks me for password, and I'm entering the wrong password intentionally. So you see 2 attempts remain, wrong password. Now I will enter the wrong password again, and this time it will tell me only 1 attempt remains. Again wrong password. Again I will enter the wrong password. This time it will block me for 60 seconds. Yeah. So you are blocked. Wait for 57, 56, so on and so forth. Now I'll have to wait for this timer to get to 0. Then again, after this timer gets to 0, it will ask me to enter the password again, and that time I will enter the correct password. Now this time I will enter the correct password and proceed to the view log, clear log, change password menu. So let's just wait for 30 more seconds. Yeah, so now I will enter the correct password. I will enter the correct password. Now you can see the view log, clear log, and the change password menu. All these different menus are there. So view log captures all the events that I did in the beginning, the event changes, that is collision event. I was changing the gears using RB1 or RB2, the speed, everything, the time, event, and speed. All of these 3 things were captured and saved in the view log. So I'll just open the view log and show it to you. All the recent changes just now that I made, the gear changes, all the recent events were captured. The speed was captured, the recent gear change was captured, time was captured, and I can just navigate to all the different recent events just now that were captured. I can just navigate to see all of them. This is the view log menu, and then we have the clear log menu. So I'll just navigate to the clear log menu as well. If I go to the clear log menu, then it will clear all those events that I just saw. Though all those different events that I recorded, it will just clear all of them. So if I press it, so logs cleared successfully. And if I go to view log now, it will show me no logs are there because I just cleared all of them. Then we have the change password, so I'll just show the change password as well. So coming back to the change password option, so if I just enter the password again, yeah, so now if I want to go to the change password menu, it will ask me to change the password. So if I want to change the password, it will ask me to enter new password. So if I enter both the passwords different, the new password and the re-enter one password, if I enter them different, then it will show that change password has failed because the passwords did not match. So I am intentionally entering the different passwords, so it says password change failed. So these were all the different things that my black box project can do. And yeah, so thank you for listening very carefully. And yeah, thanks a lot.